Hey guys, Buildzoid here, and today we're gonna be taking a look at an HD 7970 6 gig VaporX edition from Sapphire.
I can't keep it up. Anyway, we are taking a look at a card from Sapphire. It's the HD 7970 6 GB edition, and I've done some heavy modifications to it. As you can probably tell, because there's wires hanging off of it here, and the autofocus is on, so that, you know, you can all, like, go and complain that your eyes aren't working. It's a webcam. What can I do about its focusing capabilities? Yeah, and obviously you can see I removed the shim around the GPU core here, which this is, like, basically it's delidding an HD 7970, which, like, yeah, it sounds ridiculous, but it is necessary, because the thing about HD 7970s is that the metal piece going around the core is actually taller than the GPU core itself. So if you want to replace the heatsink on the card, because if you look at a heatsink, this is the stock cooler for the card, you can see that it has this raised portion in the middle of the vapor chamber. If you don't do that, and if you just put a flat base heatsink on this thing, without removing the shim, or, well, without removing the protector, or getting a shim between the core and the heatsink that you're applying, this thing is going to run really hot, because you're going to have a few, like, fractions of a millimeter worth of thermal paste between the GPU core, or possibly air if you use the dot method, then, yeah, it's like, you're just going to have, like, terrible thermal paste contact on one of these. So, basically, had to remove the metal sort of die guard thingy, which I did that with a box cutter blade, heated it up, and then basically jammed it in through the corner over here, worked it gently around, and, you know, eventually it popped off. It took a little bit of the, like, the top layer of the substrate with it, but there's no actual short circuit. It's just visual damage, though it did, like, take off some of the green. So, not really sure about that, but it didn't expose any traces, so, and the card still works. So, not a problem. It's just, yeah, it looks as violent as it was. This is not a pleasant operation. And unfortunately, it's not like you can really get a delid tool for a graphics card. You just gotta shove a box cutter in between the heat spreader, well, between the die guard and the substrate, which kind of sucks. It is really risky, but the card survived, so can't complain. And what else is there? Well, let's talk a little bit about why I have this card before we get into why this card sucks in so many ways. And then I'll talk about some of the ways it doesn't suck. Because this is an HD 7970 VaporX 6 GB edition. And basically the story goes, my second GPU ever, okay, the second graphics card I ever bought was an HD 7970 3 GB VaporX edition. Okay? And I bought that card after having a GTX 590, and that the GTX 590 failed, and we got it RMA'd, but I got the HD 7970 to replace it eventually. And the thing about the VaporX 7970s is none of these have working software voltage control. Okay, I've heard people say that it works. I've heard that some later revisions work, but this card and the card I had never had working software voltage control. There is simply no way to get these cards to overvolt using Afterburner, or even special versions of Afterburner, or, like, tricks or GPU tweak. No software can get these cards to overvolt. I don't know why, but it just doesn't do overvoltage. And the main weirdness about that is that this voltage controller right here, this chip, you can actually, well, let's see if you can read that. Focus, damn it. No, this camera just sucks. Focus. Come on. It's literally a square. How can it be so hard to find a sharp edge on that? Idiot. Yeah, the freaking webcams just... No, there, now it decides to refocus itself. You're stupid. Did I tell you that, camera? You're stupid. Cool. Anyway, That's a Chill H228G voltage controller. It's really common for HD7970s. All the other cards using this, except the Vapor X line, has voltage control. Not the Vapor X line. There's something weird that Sapphire did to their BIOS that locks these cards out of voltage control. Don't know what it is, but it's an issue. You know, hard mods solve all issues. And that's actually, like, I very much consider this card sort of like a project thingy, where it's just, you know, test stuff on it. But anyway, back to my story. So I got one of these after a GTX 590. The GTX 590 was a horrific overclocking letdown. Basically, the GTX 590s don't overclock at all, and then eventually the card died, so obviously, well, actually, it didn't die, but it had like a it had a faulty thermal probe or something like that. So basically, it would shut down at 85 degrees instead of 95, because that's where the thermal cutoff point. I know it's like 105 for NVIDIA or something. It's like really high, and the card was shutting down at 80. So that was a problem. But this card right here, so, you know, next card I get is a Vapor X, and it doesn't have voltage control. So I got into overclocking super quick. Like, I discovered it super early on, and I fell in love with it really fast. And so I get a Vapor X, and there's no voltage control. So I start looking into hard modding, and that's pretty much the card that sort of got me into learning how to do physical volt mods. I never actually did any physical volt mods on that card, but I did start looking into them and learning about them due to that card not having working over voltage. Though I think I kind of eventually got some hacky way to somewhat get voltage control or something. Like, I remember that the card never went above 1200 megahertz core anyway, so whatever I figured out didn't work that great anyway. But yeah, so this card, you know, started it up, same issues, and hard mods, here we go. And the cool thing is, this is a CHL voltage controller, and they're made by International Rectifier, and they share the same kind of basic circuit design for their sensing setup. And actually, power and, like, the basic design of a lot of things in, like, International Rectifier voltage controllers is just shared by all of them. So this was a really great opportunity to practice volt modding these for when I want to volt mod Vega, though apparently Afterburner now has voltage control support for Vega, but I still think plus 100 millivolts is not big enough, and I don't know how to mod Well, I might be able to figure out how Afterburner does it, but we'll see. Personally, it's just like, when you have a soldering iron and a datasheet, it's so much easier to do a volt mod than try figure out how to get the stupid software to do what you want, that often I'll just go with the volt mod. And this card is very much a case of that, as you can clearly see. So the volt mod is, you know, my usual style of volt mod. So I do my volt mods a little bit different from everybody else. I use 3 wires, which is actually necessary for the international rectifier type voltage controllers, because basically the problem with these voltage controllers and their and volt modding them is that the way they're configured is there's basically a wire going from the sense pin of this voltage controller to a capacitor behind the core, and then there's another wire from the like the ground portion, you know, the negative side of the sense pins to a capacitor behind the core, and it's literally just a wire. Most other voltage controllers will have a voltage divider before the sense pin. So like on a NCP 81022, you'll have a 2K ohm resistance towards the core and another 2K ohm resistance to the ground. And this voltage divider will basically make sure that, like, it's really easy to mod that card because you just buy a 20K ohm potentiometer, put it in parallel with the, you know, you put it from the pin to ground, and bam, you got voltage control in the positive direction. This card, you can't do that, because normally the resistance here from the voltage controller to the ground is like 5 ohms or 4.5 ohms. It's really low. And from the chip to the GPU core, it's like 2. So you can't just slap a big 10K ohm potentiometer between this voltage controller and ground and get voltage control. It's not going to do a damn thing. So the solution to that is you desolder you desolder a single resistor, which is something I finally learned on this card, but on a different voltage controller. That one, I desoldered one resistor, nothing changed. I desoldered another resistor, and finally I got what I wanted. Which at this point, a lot of you are probably cringing like crazy about, you monster, and how stupid are you to do that? It's like, oh no, it didn't work the first time, we gotta do it again. But, well, I mean, I've kind of, like, in the past, I've also just cut the voltage sense trace. So, you know, it's not really a departure from my worst. This is actually better, because you can actually replace resistors. You can't fix a cut trace. Well, you can fix it, but you can't mask that you've done it. Like, you can't do it cleanly, because there's a great big freaking hole in the PCB. Well, it's not huge, but, you know, you end up digging out a tiny little trace. It leaves a bit of a mark. Whereas this, you know, as long as I buy some 0 ohm resistors of the right package size, bam, it's solved. It looks like new. So this was a, you know, pulled off 2 resistors for that, and then the resistance basically from the controller to ground went up to 4,000 ohms. And ultimately, it'll never go past 20k, because the reason why the voltage controllers from CHL don't have a voltage divider on them, or at least the reasoning given in the datasheet, like, they're like, do not put a resistor between the voltage controller and the thing it's monitoring voltages for, because there's a 20k ohm pull-down resistor inside the actual chip itself. So if this was just like, if you had the chip alone, and it wasn't actually hooked, like the sense line wasn't hooked up to anything, it would still measure 20 kilo ohms to the ground pad of the chip. So there's kind of a hard limit how high the resistance on one of these can go, and obviously if you put a 10k ohm resistor between this and the core, then you have a 1 to 2 voltage divider at the actual pin itself, which you don't want. So these are done without any kind of voltage divider between them, which makes them really hard to volt mod unless you start removing components. So remove the resistors and bam, we got voltage control working. And basically it's 3 wires because I disconnected the Vcore line. Because ultimately what causes that ridiculously low resistance that you measure is the resistance of a GPU core when it's turned off, like say this HD7970 is about 2.5 ohms. So if you measure from the pin on the voltage controller, then through the core and to ground, you get 4 ohms, because there's obviously some, like those 0 ohm resistors. One of them was 0 ohms, the other one was actually like 1 ohm. So not really much of a resistor, but still, it was 0 ohms for one of them, 1 ohm for another. Then there's some trace length, potentially some other resistor somewhere on the way, and you end up with something that has single-digit resistance because the GPU core is a single-digit resistor. Similarly, if you measure the, like, say, the memory rail, like the memory sense pin to ground, most of that resistance you're going to measure is going to be the memory's own resistance. So yeah, pretty annoying, and you basically have to lift off the entire positive side of the input and then rewire it. So red wire goes to Vcore, and it actually goes to Vcore where Vcore originally came through on its own. So that resistor I lifted off, one of the resistors I lifted off connected the chip to the connected the chip to the trace that goes to the back of the GPU core. So basically the ending of that trace is the red wire. So I'm still using that old sense line, so it's actually measuring the voltage from the same place as always. And then the black wire is just ground, which I grabbed also very close to where the original ground trace is. I think actually off of the original ground. No, actually I pulled that one here. Yeah, so I pulled that off of the front, like the ground here on the VRM, which admittedly it'd be better if I got it even closer to the core, but I've had the card on the scope basically the entire time that I've been working with it, and I haven't seen any anomalies, so this works just fine right now. The white line is obviously the feedback pin itself. So that's how one of these is wired. The switch here, all the switch does is it pulls it connects the white line to the red line, so basically if I switch that on, the volt mod is disabled because it's basically rewired 0 ohms to Vcore as it usually is. And then if you turn it off again, then, you know, the resistance goes to whatever's through the potentiometer, which this is a 1k ohm potentiometer, and I use 1k ohm potentiometers because you can slap them on literally anything. If something has a 10k ohm resistance to ground, you can put a 1k ohm resistance potentiometer on it, and boom, it works. Like, these are like you can override basically anything with a low resistance potentiometer. Whereas if you have a really high resistance one, you need a circuit that starts with a relatively high resistance to be able to skew it. So that's why I use 1Ks, not like 10 or 100Ks. So that's that. Let's go to the back of the card. I don't think there's anything on the front left. The back of the card, I've gone to town on. More so than the front of the card. As you can clearly see, we have capacitors freaking everywhere. And this actually made a pretty major difference to the peak-to-peak measurement of the... So basically, most of these are for Vcore. I've not really checked the memory VRM, and I've not had any improvement in memory overclocking on the card with these extra capacitors on the memory VRM, which is actually really surprising, because in the past I've seen cards where you'd have single-phase memory power, which this is an 8+1+1 VRM setup. It, like, Sapphire markets it as a 8+3, but this right here, this is not 3 phases. This is 3 inductors, and 2 of those are for the memory and hooked up to 1 phase, and the third one is actually the auxiliary VRM, so that's for the memory controller. So I guess, you know, it's not completely wrong to say that the memory is powered by 3 inductors, because it is. One of them is for the memory controller and the other 2 for the memory chips, but I guess you can consider that the memory system or whatever. But yeah, Sapphire markets this as a 3-phase. It's not a 3-phase, it's a 2, it's like a 1+1. And ultimately, considering the history, like, say the GTX 1070 from Asus, that thing, that had a single-phase memory VRM, and that picked up some megahertz when I added extra capacitors to the memory VRM, so I figured, okay, well, this has 6 gigabytes of GDDR5. This memory setup pulls a ton of power. This is going to benefit a lot if I add some extra memory, if I add some extra capacitors to memory. Turns out it didn't benefit at all. The memory on this card clocks stupid high regardless of what I've done. This thing would do 1930 megahertz on the stock air cooler because it cools the memory really well. Even though it doesn't really do a good job of cooling the core, which we will get to that. But yeah, it does a great job of cooling the memory, but yeah. Card would hit 1930 on the stock air cooler, and then once I put it on a core-only water block, so, one of those GPU water blocks that only goes on the GPU core, the memory lost like 30 megahertz for short benchmarks, and then 20 megahertz for long benchmarks like 3D Mark Vantage, so 1880. But the capacitors had no impact on that. The card was hitting that before and after. Well, I don't know if it was hitting that before on the water cooling, but I know on air cooling it was doing 1930, and then when I switched to... when I added the capacitors and was still on air cooling, it still did 1930. It didn't pick up a single megahertz. So, yeah, I'm surprised. The memory VRM is actually not bad out of the box, even though it's a single phase, because those are usually terrible. But then again, Sapphire have gone ahead, and you do have, you do have 2 capacitors right coming off of the VRM itself, and then you have tantalum capacitors, basically for every 2 memory chips. So you have one here for these 2, you have one here for those 2. I'm not actually sure what that one's for. I assume it's also for memory. So that area would have an extra one. Then, and you basically get a single... Well, I'm not sure these are tantalums. These might be aluminum polymers in SMD package. But either way, it's be these tantalums or aluminum polymers, this type of capacitor is really good at its job. So for lower frequency stuff, these are awesome. And they don't compare to ceramics, but they're still really good for everything, that ceramics cost too much for. These are awesome in terms of actual, performance, and so I'm not super surprised that the memory didn't care about the extra, couple thousand microfarads I added on. But, yeah, so the memory VRM is surprisingly good. The auxiliary VRM, similar story, absolutely no benefit from all the extra capacitors I added on, though that's also a single phase. And honestly, I had no expectations for that one. I've never messed with it before. So, in terms of the memory setup, the Sapphire has done a pretty good job. The Vcore VRM, on the other hand, was just messy as hell. This thing was spitting out some 270 average and 300 millivolts peak-to-peak maximum voltage regulation. So this thing was atrocious. Well, not atrocious, but it was, well, actually, it's by far the worst I've measured, because this was peaking at 1.4 volts, while the core was getting an average of 1.2. So it, like, the average voltage, the voltage that you would, like, measure with a multimeter, this was overshooting that by 400 millivolts. Admittedly, on very short, I mean 200 millivolts, on very short spikes, but it was still overshooting it heavily. And in terms of undershoot, it was going down as low as 1.1. So you had that 300 millivolt spread around 1.2 volts. Now, interestingly enough, when I piled on all these extra capacitors, that actually improved a huge amount. I went from sort of 270 average to 300 peak, to down to like 200 average and 230 peak or 240 peak. So roughly 60 millivolts off of the previous results, and no improvement in overclocking. And there's a really good reason for that. Well, there's two kind of reasons for that. First of all, the minimum voltage didn't really change. It was still bottoming out at like 1.11 instead of 1.1. So, 10 millivolts up on minimum, and it's like, well, I'm not really surprised it didn't make much of a difference. And then peak voltage, however, came down significantly. That came down from like 1.4 all the way down to 1.34 to like 1.34, 1.33. So significant improvement in the spikes upwards, but no real improvement in the dips, which I think has something to do with basically like Sapphire is using these like these chokes are unique to Sapphire, and Sapphire makes them a big deal, but they basically go through the PCB, which it looks cool, and it is something unique and something I've never seen before. But if you think about how a buck converter on how a VRM on a GPU is laid out, this makes zero sense. You don't want to be putting holes in between your GPU core, your load, and your and your MOSFETs, right? Because the problem is, when you think about it, you have power, you have current going from the inductors to the core, and then it has to go back from the inductors and into the other side of the inductors. It has to come through the other side of the inductors, the side of the inductors facing away from the GPU core. That makes zero sense. That literally makes zero sense. Why would you put a great big freaking hole in the shortest possible path that it could possibly take, right? Because ultimately what ends up happening is you have a ground plane that has all these holes in it, so it has a higher resistance than if it was just a solid piece of copper, which it would normally be on most cards. So I imagine that actually is part of the reason why this card was having those really high voltage spikes, because the voltage controller has to compensate for all of that extra resistance in the VRM setup. But naturally, the extra capacitors cleaned up most of that because, well, that's kind of their job. They soak up the extra spikes. But I guess they also didn't really help the minimum voltage very much. And actually, in terms of capacitor selection, I have 8 little... Come on, camera! You were focusing when I was doing the test runs before. Stop being stupid. No? Come on, focus. Okay, we'll just do it by hand. Give me a second, people. This is gonna... There we go. I wish I had a cameraman. But you can see I have a bunch of little multi-layer ceramics just stacked right behind the core. Those are all on Vcore. These big ones are on the auxiliary rail. They don't do anything. Quite frankly, they don't do a damn thing. But yeah, those are all on the auxiliary rail. Then this copper clip right here, you can see, that is what I had the oscilloscope hooked up to. This is the ground for the oscilloscope. So that's where I was taking my measurements for the core. Peak to peak, ripple, noise measurements. That's where I was taking them. And yeah, and then the actual Vcore Vrm itself picked up a lot of extra capacitors. So we have 820 microfarad FP series capacitors from Nichicon right here. Then there's some extra multi-layer ceramics down on top of the existing multi-layer ceramics, which is what I also hooked up the 820s to. Then we have these 4 packs of tantalums. These are 330 microfarads each. And there's 4 of those again. So there's like 16 330 UF capacitors on there total. And then we have FP series Nichicon's 1500 microfarad. So yeah, that's the capacitor setup there. I might end up swapping these out for the big 1500s, because these aren't really saving me that much space. I wasn't sure if I might not do something to the, the multi-layer ceramics around the memory, but at this point it's just like, nah. So these I might take these off again and replace them with something bigger. But yeah, that's how I knocked off some 70 millivolts of peak, of voltage variance off of the VRM. Though it absolutely did nothing for the overclocking capabilities of the card, unfortunately. Which, let's talk about that. Let's talk about why this thing clocks as badly as it does. This HD7970 has a 64.5% ASIC. That's pretty bad. But more importantly, on 1.2 volts on air cooling, it hits 1190 megahertz core clock for benchmarks. That's not so bad. Unfortunately, that's not fully stable. That's like artifacting. It's just like it finishes the benchmark and scores higher than if it was at a lower clock. That's the only criteria here for if the clock is viable. So it would finish at like 1190 for benchmarks. Not great. And cranking more core voltage after I hooked up the volt mod, because obviously, oh right, I forgot about the autofocus. Or the lack of thereof. So let's fix that. But unfortunately, after cranking more core voltage, I was not getting any increase in overclocking. Like, the card was still peaking at 1190. I could kinda almost run 1200 if I also bumped up the memory controller voltage a little bit, because basically my idea behind bumping up the memory controller voltage was, well, this does have 6 gigs of VRAM. I wouldn't be that surprised if the memory controller was having a tough time. But yeah, that was wrong. It kind of helped with stability at 1200 megahertz, just like the smallest amount, but at the same time it introduced like black screen issues, and it still didn't run fully. Like, it ran for a bit, but ultimately it still crashed, which admittedly without this, it crashed immediately pretty much, but yeah, still didn't make it viable. And this is one of those voltages, you push this one too high, and the card goes bye-bye very, very quickly. So I went back down, I backed off of that one after I realized it wasn't really doing much of anything. Vcore, I could go all the way from 1.2 volts to 1.35. No increase in clocks whatsoever. The card was still hitting 1190. Actually, at 1.35 volts, it was less stable than at 1.2. And there's a very simple reason for that. This thing is leakier than a Calander. Like, this thing is so freaking leaky. It's just ridiculous. So, slap a water block on it, and suddenly it can run on 1.3 volts. Well, 1.32-ish. And so now, it runs 1.32 volts, and it does 1275 megahertz. So that's an 85 megahertz core clock increase, but just swapping cooling systems, which is awesome. And that's 1275 megahertz in Vantage. If I was actually doing comparisons against Firestrike clocks, I picked up a whole 100 megahertz, because Firestrike, this would finish at 1285. So yeah, this thing really needs extra cooling, which is why I'm hopeful that it'll still do decently on like liquid nitrogen and dry ice, because yeah, on air cooling this thing sucks. On water cooling it's pretty bad. There are HD7970s out there that hit 1300 to even 1400 megahertz on water cooling, and this thing is still, it's getting almost 1300, but almost 1300 isn't 1300, and 1300 plus is a lot more than almost 1300. So yeah, this is not a great card on ambient, but I'm hoping that on liquid nitrogen it won't be too bad, because it evidently really likes temperature drops. Because going from the stock cooler, which I think this would hit like 80 degrees before the card crashed, to the water cooling, dropped about 35 yeah, no, wait, 25, no, 35, yeah, 35-ish degrees from the temperature of the core. So, not the biggest temperature drop ever, but a really big increase in available core clock. So I'm hoping that, if that trend continues, if I pick up another 75 megahertz for every 35 degrees down, this thing is going to be absolutely insane. Because, well, actually, no, it's not even 75. It's like 90 it's like 90 or 85 megahertz. So, if we go from 45 to 10, that'd be like 1350 for 3D Mark Vantage, Then we go from 10 to minus 25. It doesn't work like this in reality. I'm just, speculating here. Gonna get my hopes up to have them smashed down when I inevitably find out it doesn't clock that good. But, minus 25, you'd be looking at like 1425. So minus 50, minus 60, this might be doing 1500 megahertz, which and then HD 7990s can go as low as a minus 100, but the first thing I'm going to be running this on is dry ice, as I do plan to get some dry ice while waiting for my next delivery of liquid nitrogen, because I'm dry. As in, there's no liquid nitrogen in any of the DWARs anymore, so yeah. We need some other kind of coolant, and dry ice seems like a pretty viable option. Plus, it's really easy to work with compared to liquid nitrogen. None of the constant babying the temperatures because, well, dry ice isn't cold enough to cause cold bugs and other issues that liquid nitrogen does cause. So, yeah, that's planned for this card. And I've like... So this is funny. I decided to reshoot this video because the first take was like 25 minutes, but now I added all the stuff about the voltage controllers and the plans, and it's like, oh, now it's 30 minutes. And we're not stopping here, guys. But yeah, so I do plan to run it on dry ice very soon. Watch out for that. That will be a live stream. It will be up on the Twitch. Should be pretty fun. I'll also be running a 6950, like I'll be running it with the 6950X. I might put it on the 7700K. I'm not entirely sure. Like, I'm buying 25 kilograms of dry ice, and basically the plan is to use it all as fast as possible because dry ice goes off quickly. And so I do plan to be benching a lot of hardware. There's going to be a bit of Vega. This is definitely going on dry ice. I might throw a Fury card on dry ice as well. So, definitely watch for that. That should be pretty awesome. So, yeah, and that is the current state of my HD 7976 gigabytes Vapor X edition. And ultimately, is it a great card? No. It's kind of terrible, to be completely honest. And you know what? That makes sense, because the thing about how these were made is... I'm just going to keep going on and on forever. There's so much about this card. Like, there's so much, like... It was a card I owned at one point. So, I did a ton of research on one of these. Well, on these at the time. But the thing about this card, this is the 6 gigabytes Vapor X edition. This is a binning reject. So I'm not really surprised that it doesn't clock that great. Because Sapphire had a HD 7970 6 gigabyte card using this exact PCB called the Toxic Edition. And the Toxic Edition ran 1200 megahertz stock, which was crazy. And actually, well, it shipped at 1150 megahertz, and if you press the BIOS switch, it would put you onto a 1200 megahertz BIOS, which was crazy. Like, that was a 7970 shipping at 1200 megahertz. That thing could almost keep up with 780s out of the box. Like, that was a crazy 7970. It also pulled a ton of power, and because this heatsink is kind of anemic, it was incredibly loud, but it was awesome, And unfortunately, this is a binning reject for that card, so I'm not hugely surprised that it doesn't clock that great, because if this was capable of 1200 on air, Sapphire wouldn't have sold it as a Vapor X edition. They would have sold it as the Toxic version. But it is very much sort of like I had one of these nostalgia card things, and I've just had fun just messing with it, and I definitely like the working on the volt mods for the CHL voltage controllers, which the auxiliary rail, this is also a CHL voltage controller. This is a CHL 8225, which that runs 3+2 phase. No, 4+1 or 3+2. One of the two. I can't remember right now. It might be, it might be completely... Yeah. Oh, yeah, that was the big selling point for this series of voltage controllers. These are completely reprogrammable. This is a 5-phase that can do 1+4, it can do 1+1, 1+2, 1+3, 1+4, or it can do 1+3 or 2+3. So you can run basically any voltage phase count configuration as long as it fits in 5. And the same goes for the CHL 8228. I think that was you could run anything from a 4+4 to a 1+7 setup off of one of these. These are pretty cool voltage controllers. They're not super high frequency, though. They go up to 1.2 mega, or 1.2? No, I think it might just be 1 megahertz. So yeah, these don't go to some super high switching frequency, but they do have the cool phase reassignment capabilities. But yeah, so ultimately I learned how to do the, volt mods for these voltage controllers a lot less messily. I got a ton of practice soldering in awkward places, right behind the core and such. Though, again, my soldering still isn't exactly artist's grade stuff. Like, it's not beautiful, but it's actually really ugly, but it works. So, nothing's falling off and everything is electrically connected. I'm taking it. I'm not going to complain that it's kind of ugly. Yeah, so far this card's just been a blast. I can't wait to see what it'll do on dry ice and liquid nitrogen. And I don't intend to hammer it, really. I don't want to kill this card. So I just kind of plan to run it, 1500, like wherever it stops comfortably, I'll stop and call it a day, because I do want to keep this as a sort of like collector's thing. Unless I get my hands on a Toxic Edition. If I get my hands on an actual Toxic Edition of the one of HD 7970, then this thing is going as is. Like literally, I'll just throw this up on the junkyard and I'm hunting down that Toxic, and I'm getting that, and I'm doing the same thing to the Toxic Edition, and we're running that instead. I don't know why. I just told you how this PCB is flawed in so many ways, how voltage control doesn't work, but I just think, crazy 6GB VRAM HD 7970. I mean, ultimately, I'm very much one of those people who overclocks hardware to appreciate the hardware. That's like why I would go and get like a mini ITX motherboard and put it on liquid nitrogen. I know it's completely stupid. And a cheap one at that. Like, it wasn't a Maximus Impact or anything. It was just the cheapest gigabyte motherboard that was mini ITX. And I'm like, okay, yeah, let's put this on liquid nitrogen. That's a great idea. It's just like, and similarly, this is not the best HD 7970 to run on liquid nitrogen. The Lightning or the DirectCU2 cards would be better candidates for that, honestly. But I just think this thing is cool, and that's why I want to run it on liquid nitrogen. Even though I'm pretty sure it won't score very well. So, yeah. That is actually it for this video. Thank you for watching. Like, share, subscribe, leave a comment down below, or questions or whatever. If you have any complaints, you can leave them down below as well. I might read them, and I might actually care about your complaints. But, we'll never know if you don't leave them. So that's it for this video. Thanks for watching, and see you next time.